I always ask people to read. So, Trevor, you want to start with number 1 here?
The prerequisite chapter, the material and the prerequisite skills that class will but that we will then not throughout this semester. The anticipation guide below represents the samples of this prerequisite material. Remember, the exercises below are a jumpstart material review of key prerequisite skills.
Okay. So the anticipation guide is this little table here. And as you can see, if you look over in this particular column, you see it has examples. This is the types of examples you can anticipate from P2 to P4. All review from 096, okay, or prerequisite material. So what I want you to do individually is I want you to read each one of these, 1 through 9, and put a check here beside any one of these that you agree with. It's like true or false, but you can put true in if you want and false in if you want. Then I want each group to discuss these and come up with a consensus. So each group is going to be reporting, when your group is done and you have this column filled in after you discuss it, put up your flag and I'll come and talk to you about each of these answers, okay? So first you work by yourself and you decide whether these are true or whether you agree with them. Then you work with your group to reach consensus. So you have to agree on everything. And then call me over and I'll take a look at what you all decided, okay? All right. Record this just in case someone was missing today. So I believe that most of us agreed that the first one was not true. Is that correct? Okay, so we're going to say that this is not true. So this is not true. And what would be the correct answer if we, hang on, I want to turn off Pandora. Where are you? Okay. So what would be the correct answer for this? X to the 7th, because when you multiply, you add your exponents, right? And there's a little acronym over there on the sideboard. I don't want to say it out loud because I'll probably be arrested, but that's a little acronym I made up to help students remember the rules, the exponent rules from multiplying. When you multiply, what do you do to your exponents? And when you divide, what do you do? So my students in 096 had no trouble remembering that, you know, so okay. All right, and if you miss class today and you don't know what, you can't see what's on the sideboard, ask any of your classmates and they'll let you know. Okay, how about number 2? Did we agree with this one? Do we agree with this? Yeah, okay, so this one's okay. Now what about 3? Did everybody say no on this one? You said it was true. And how many people said no, it wasn't true? How many groups? Table 2, table 3, okay. So everybody else said it wasn't true. And it is not true. And the culprit here is this thing right here, that big plus sign. So no matter where you are in mathematics, whether you're in arithmetic or algebra, the only time you can add things is when they're the same. You can add smiley faces to smiley faces. You can add the tens to the tens, the hundreds to the hundreds, the ones to the ones. You can add x's to x's, y squares to y squares. You can add square roots of 2 to square roots of 2. But their name is, the thing you're adding here are called square roots of 2. And it's just saying, how many of these things do I have? I have 21 of them, and I have 10 of them. There's a big difference between adding and multiplying these two things. So this is 31 square roots of 2. So this is 31 square roots of 2. Okay. All right. Now this one, I intended to write this, hoping to catch people. See, I meant to put 16x to the 4. I didn't want it to be that blatant that it was wrong. And if I had put 16x to the 4th plus 1, I may have caught more of you, because this is a biggie. So we just talked about exponent rules. And we know that there's an exponent rule that comes down and attaches itself to everything in the parentheses. But what you forget is that the only thing exponent rules apply to are multiplication and division problems. What kind of problem is this inside the parentheses? Subtraction. This is a binomial. So this is one of the hardest habits to break when you're a student. This is 4x squared minus 1 times 4x squared minus 1. So you have 4x squared has to multiply. You have to distribute it to multiply both of those. And the negative 1 has to multiply both negative, the 4x squared and the minus 1. So this is what you typically call FOIL if you've done this in high school. So this is 16x to the 4th. Once you do it all out, minus 8x squared plus 1. So this is not true as well. So this is something that if you need to train yourself on, just do like 10, 15 of these. Just make your own up, like x plus 2 squared, x plus 3 squared, 2x plus 1 squared, and just do it so that you don't fall into this trap. Okay, how about P number 5? Is that true or that's okay? Yeah, and that's the other part of our little acronym up here. You've got 24 divided by negative 2, which is your negative 12. You see that you have 3 more factors of x on the bottom than you have on top. So if you reduce this, you'll have 3 factors of x on the bottom. Or if you use your exponent rule, that's right over there, the D for divide and the S for subtract EX. 2 take away 5 is negative 3, so that says you're on the bottom. Now this one, again, you have 13 on the top and negative 2 on bottom. When you subtract negative 2 from 13, you get 15. So this one is true. Yeah. This is okay. Now this is the one giving everybody problems, so we'll come back to this, okay? How about number 7? What did we say for this, the back table, since you had a few, what'd you get for this, T.O.? True, because, and I did this purposely. This is very similar to number 3. Notice you're adding here and you're multiplying here. So this problem is what we call a subtraction problem. Why is it subtraction? Because it's the last operation you would do. So you add up these two first because they're like 2x squared. You've got to figure out what this box is. This is where you're multiplying, so you add your exponents. And then these two, in order to add or subtract, they must be the same, and they're not. So this is exactly how you leave it. So I agree with that. This is okay. How about this last one, number 9? What do we have for that, Caleb? You got that one wrong? Okay. Oh, that's not right. So this is not okay. And what would the correct answer be here, Caleb? Yeah, because you have to distribute the subtraction sign through, which changes 4x to minus 4x and subtracting 7 to adding 7. So that's negative 1x plus 12. Okay, so the last two most people had trouble on was 6 and 8. Okay, so number 8 is multiplying radicals. This is just like this particular setup isn't the most helpful because you can't do anything with the square root of 6. You could simplify the square root of 50. So sometimes you just want to throw in the towel and start at the beginning. And that's one of these situations. Just start from scratch and say, I'm just going to multiply these two and start all over again. I'm just going to put them under one radical and start with the square root of 300. And so your job now is to say, what's the largest perfect square that will divide into 300? I agree 25 divides in there, but it's not the biggest. What's the biggest perfect square that actually is a factor of 300 or divides into it? So we got 1, 4, 9, 25, 16, 40. Right, biggest perfect square is 10 squared, which is 100. So square root of 300 can be broken up into the square root of 100 times the square root of 3. And now you say, I'm going to call the square root of 110. Square root of 3 is irrational, and that's where we're set there. Okay, so this is okay. And now number 6 seemed to be the big one that most of you had difficulty with. So let's talk about this particular one. 2/7 to the 0 power. Notice that this is in sections P2 and P3 in your book. Okay, one deals with just exponent rules and one deals with having fractional exponents. So 27 to the 0 power minus 32 to the negative 2/5. And again, this is a subtraction problem. So I put my boxes around each term. That's what we call the pieces of adding and subtracting. And now I have to do each one separately. So I heard someone say this just disappears. Well, it really doesn't. It's not 0 times that. And even if it were 0 times that, it wouldn't disappear. It would be the number 0, right? So there's an exponent property that says any number except 0 to the 0 power is defined. You're not going to find this in your soul anywhere. It's defined to be 1, except the only number in the whole wide world A can't be a 0. 0 to the 0 power is not defined. Okay, so this just becomes a nice big number 1. And now we've got to deal with this thing called 32 to the negative 2/5. So there's a lot going on here with 32 to the negative 2/5. And this is usually the part that most students need more review on, are these fractional exponents. So that should be, if you're having trouble with these, that should be where you focus in P3, okay? Do a few more of these problems maybe than even I gave you for homework till you get them down. So there's a lot going on here. In fact, there's 3 things going on here. Matthew, do you mind shutting the door for me? Because I think people are going to start walking by. There's 3 things, okay? And in reality, it doesn't matter which of those 3 things you do first. But practically speaking, it's without a calculator, it's a lot easier to do one of those things first. And that is to make this base, the number 32, as small as possible. So I always start with the denominator. The denominator tells you what root. It tells you what root it's asking you to define. So this is asking you to find the 5th root of 32. The 5th root of 32. In this time of year, we're harvesting a lot of roots. And if you harvest beets and potatoes and carrots and stuff, and you're actually living maybe in a place where you can store them besides your refrigerator, where would you store them? Your roots. I think I'm really starting to feel my age because nobody does this anymore. In the cellar, right? So roots go in the cellar. The roots go in the denominator. So you're going to ask for the 5th root of 32. That's the thing we're going to do first. So we find the 5th root of 32, which is the number 2. So this problem now becomes this problem. Once I find the 5th root of 32, which is 2, this is what my problem gets reduced to, because I've taken care of that. I've done that first. Now it doesn't matter which of these next things you do. But then I always go to the numerator and say, what is this asking me to do? It's asking me to square 2. And then finally it says, flip me. Take my reciprocal. Because that's what a negative exponent means, is it puts 2 factors of 2 in the denominator. Because if it was just 2 squared, the 4 would stay in the numerator. But this is asking you to put it in the denominator. So there's your final answer there, 1/4. Okay, so as you can see, there's 3 actions. 1, 2, 3. Now the only time I do step 3 before I do step 1 is if this is a fraction to begin with. Like if this was 1/32, I would actually flip it first and call it 32. And then I would take the 5th root and then I would square it. So if this was 1/32 to start, 1/32, the answer would be 4. They would just be reciprocals of each other. Brendan? No. Coleman, right? Oh yeah, I haven't finished. I was just getting that box. Okay, so that's the answer there. So this box now becomes 1/4. Right? So this box is the number 1/4. This box is the number 1. And what's 1 minus 1/4? 3/4. So there you go. Okay, I'll see you all on Friday. Have a great day.